What if I told you your Lambda functions could be running half of the time and costing less? By the end of this video, you'll know how to easily find the best memory configuration that balances performance and cost, making your functions faster and cheaper. My name is Daniel Chio, and I've been working for 4 years with cloud technologies, helping customers optimize their workloads daily. So let's get started. Here's what we'll cover in this video. We'll start by pointing out common challenges related to Lambda functions. Then I'll explain what we're aiming to achieve. After that, we'll move to the technical part, starting with a quick refresher to make sure everyone's on the same page with Lambda fundamentals. Then, I'll walk you through a hands-on demo so you can see exactly how to apply this yourself. And finally, I'll share some additional tips and important information. Here are the key challenges we'll tackle. First, your functions take too long to execute and compromise user experience. Second, you're over budget and need a way to reduce expenses. Third, you know there's room for optimization, but manually testing different memory settings just isn't realistic. Our goal is to find balance between cost and performance by setting the most efficient memory configuration quickly and with minimal effort. Before we jump into the hands-on part, here are a few important things to know. When you create a Lambda function, it starts with 128 megabytes of allocated memory by default. Memory allocation is configurable, and it can be set between 128 and 10,240 megabytes. CPU power scales proportionally with memory, so the more memory you allocate, the more CPU your function gets. At 1,769 megabytes, the function has the equivalent of one vCPU. The official AWS documentation with all these details is linked in the video description. Now it's demo time. Let's jump into the AWS's console. First, I'll show how this would be done manually. Here we have a Fibonacci function. You can see that it has default memory allocation, so 128 megabytes. Let's check how long it takes to execute. 1.75 seconds. And one more time. 1.73 seconds. Now we'll update this memory configuration and see how long it takes to execute. Let's update it to 512 and run it once again. Okay, only took now 0.42 seconds. Let's run it one more time just to make sure. Again, 0.42 seconds. So our function is 4 times faster, and it only took us 1 minute to do this. And take a look at this number. It says it allocated 512 megabytes, but it only used 33 megabytes. So this number could mislead you. You could think there was nothing to do to improve your Lambda function, but as you can see, there might be. It depends if this function is CPU bound, so it's worth trying it. Now I'll show how this can be done automatically. This is AWS Lambda Power Tuning, an open source tool available to everyone. I'll show how to use it and leave the link in the description. This tool deploys state machine on your AWS account, making it easier to test different memory configurations. You just need to click on deploy. It will take you to this link, acknowledge it, and you click on deploy. It should take from 1 to 2 minutes to deploy, so I'll be back right after. Okay, it's ready. Now let's test it. Let's go to step functions. You see a new state machine, power tuning state machine. Now let's start an execution. I'll paste this input code here and start it. I'm running the test with the same Fibonacci function for the power values of 128 megabytes to 156 megabytes, so multiple memory configurations tested at once. Again, this should take 1 to 2 minutes, so I'll be back right after. I'm back. The tool also generates a graph to make it easier to compare the results. You can access it in this visualization link. Here you can see the invocation time in red and the invocation cost in blue. We can see that 512 megabytes brings the best cost. But if you set it to 1024, it gets almost twice as fast with a small increase in cost. So it's up to you to decide now. After that, just update Lambda configuration. Let's set it to 1024. And I recommend reducing the timeout. So in case your function has some issue, your costs won't increase much. Let's run it one last time. 200 milliseconds, almost 10 times faster than a couple of minutes ago. This tool will make a big difference for you and for your customers. If you want, you can be more granular, adding other power values to find even better results. Before we finish, I have one last slide to show you. Here are a few important things to keep in mind. If your payload varies, you can set up weighted payloads to make sure you're testing with different kinds of input. This helps simulate real-world traffic and improves the accuracy of your tuning. If you're constantly updating your Lambda functions, it can be useful to integrate the tool with your CI/CD pipeline. Then you don't need to run the tuner every time you deploy a new change. It's important to know that everything will run in your AWS account. So if you're beyond AWS's free tier for Lambda and step functions, the experiments shown here using the same code and configuration will cost less than a tenth of a cent. It's not much, but it's good to know. And by the way, both the code and the configuration used are in the description. Now it's your turn. Go optimize your Lambda functions. After you tuned your function, share your results in the comments so others can see what they can achieve. I'll start.